What has made humans dare to build gigantic structures in places that seem impossible to exist in? There are bridges spanning deep abysses and vast oceans, tunnels piercing through solid mountains, and skyscrapers reaching into the clouds as symbols of humanity's limitless ambition. The MSG Sphere in Las Vegas is one of the clearest examples where massive architecture and lighting technology transform a building into a symbol of the future. Even further, the International Space Station shows that this ambition has gone beyond Earth, as humans are able to construct a structure right in orbit around the planet. Today, we will explore the most fascinating megastructures in the world, where engineering, courage, and human ambition come together to create astonishing modern wonders. At the edge of the Sahara Desert, in Morocco, the Noor Ouarzazate Solar Power Station stands as a technological marvel with a massive construction scale. This megaproject covers an area of 7,413 acres, forming a sea of mirrors that reflects intense light visible from space. The complex structure uses millions of parabolic mirrors and heliostats to focus solar energy onto absorption towers reaching 800 feet in height. The sophisticated engineering system allows the facility to produce 580 megawatts of power, enough to provide clean electricity for over 2 million people. This site represents the human effort to overcome engineering limits to create a sustainable, renewable energy source for the future. In Chile, Atacama Large Millimeter Array is a radio telescope system built in an extremely dry environment, known for its network of antennas that observe deep into space. More than 60 metal antennas are synchronized and pointed toward one region, combining signals to create a system that can penetrate dense cosmic dust. Standing among the large dishes feels like entering a mechanical network where every movement connects directly to distant targets in outer space. By processing extremely weak signals from far away, the system converts radio data into images used to study galaxies and planet formation. The system operates at about 16,000 feet, where thin air limits humans, so automated equipment handles most operations in harsh conditions. The antennas are spaced miles apart and synchronized with near-perfect timing, allowing the entire system to function as a single, unified structure. Located in a limestone valley of Guizhou province in China, the Fast Radio Telescope appears like a massive silver bowl aimed toward deep space. The dish spans about 1,640 feet across, covering an area similar to 30 standard soccer fields within its circular frame. Operating the observatory requires strict radio silence, and personal electronic devices are prohibited within roughly 3 miles of the site. Its reflective surface consists of around 4,450 triangular aluminum panels that can adjust position to focus signals precisely. The instrument is nearly 3 times more sensitive than earlier large radio telescopes, enabling detection of extremely faint cosmic signals. To preserve ideal observation conditions, more than 9,000 local residents relocated from nearby communities to reduce interference around the facility. In the heart of Norway's rugged mountains, the Lærdal Tunnel stands as a monumental infrastructure marvel that challenges the ultimate limits of modern construction. Extended over a record-breaking length of 15.23 miles, this is the longest road tunnel on Earth, carved through solid granite rock. Engineers blasted and moved more than 3.3 million cubic yards of rock to create a secure passage for year-round travel. An advanced air filtration system constantly removes dust and pollutants to ensure the interior remains fresh, even deep beneath thousands of feet of stone. Three massive caves illuminated by ethereal blue light help drivers stay alert and eliminate the overwhelming feeling of being enclosed. This impossible project has completely transformed how people travel by turning a dangerous mountain crossing into a remarkably safe and efficient journey. Located along the coast of Dubai in the United Arab Emirates, Palm Jumeirah stretches boldly into the sea as a striking symbol of engineered ambition. Created from about 3,500,000,000 cubic feet of sand and rock, the island required enough material to reshape vast stretches of open water. Powerful waves from the Persian Gulf constantly test the surrounding breakwater, which must absorb intense pressure to protect the artificial shoreline from erosion. Engineers relied on vibration compaction technology to stabilize the reclaimed seabed, reducing the risk of long-term settlement beneath the massive structure. "17 palm-shaped fronds extend outward to form nearly 48 miles of new waterfront, dramatically increasing private coastal property within the city." Valued at around $12 billion, the development transformed empty sea into one of the most exclusive residential districts in the region. Located in Hubei province of China, the Three Gorges Dam stands as a massive concrete barrier restraining the powerful current of the Yangtze River. The reservoir holds nearly 40 billion tons of water, creating immense pressure that may influence local geological stability around the surrounding region. Flood discharge outlets release torrents from heights of about 590 feet, generating violent whirlpools capable of overwhelming large obstacles downstream. The structure required roughly 980 million cubic feet of concrete, an amount sufficient to build a continuous wall encircling the entire planet. A massive shiplift system enables vessels weighing around 3,000 tons to rise past the barrier and continue navigation along Asia's longest river. In the waters of Shandong, China, the Jiaozhou Bay Bridge Megaproject stands as a mechanical marvel that challenges all limits of modern architecture. With an impressive total length of 26.4 miles, this structure established a world record for its overwhelming sea-crossing scale. Engineers utilized 450,000 tons of steel and massive amounts of concrete to create a unique T-shaped structure in the ocean. The extraordinary difference lies in the sea interchange, allowing vehicles to change directions flexibly right above the mysterious deep blue waves. Sturdy concrete pillars are specially designed to endure direct collisions from transport ships weighing up to 300,000 tons. This superstructure not only significantly shortens travel time, but also redefines human capability in exploiting and conquering nature. In Canada, Confederation Bridge appears as a continuous structure extending across open sea, where the uninterrupted horizon makes it difficult to clearly identify where the structure begins or ends. Crossing the bridge takes about 10 to 12 minutes over nearly 8 miles, creating a steady travel experience between wide open water and an unbroken horizon line. The piers use a sloped cone design that forces ice upward and breaks it under its own weight, reducing lateral pressure and maintaining long-term durability. Completed in 1997 with about 44 main spans, the structure forms a repeating pattern that creates a strong visual rhythm when observed from a distance. In winter, large ice sheets move around the piers, while summer conditions reveal calm water that highlights the gentle curve of the entire structure. Inside the bridge, post-tension cables run through the concrete, forming a hidden structural system that is not visible from the exterior surface. Across the sea in China, the Hong Kong-Zhuhai-Macau Bridge extends as a continuous system where bridges, tunnels, and artificial islands connect into one uninterrupted transport route. The full route spans about 34 miles, allowing vehicles to move from bridge sections into an undersea tunnel without breaking the flow of traffic. The project is considered the longest sea crossing in the world and a rare integrated bridge tunnel system in modern infrastructure engineering. Two artificial islands were constructed in the sea to connect bridge and tunnel sections, acting as technical anchor points within a vast open water environment. The system operates with 6 traffic lanes, ensuring high-capacity flow and maintaining stable movement of vehicles across the entire route. This route directly links Hong Kong, Zhuhai, and Macau by road, allowing continuous travel without switching to ferries or other transport methods. Stretching across the Bosphorus Strait is the Yavuz Sultan Selim Bridge, an ambitious project featuring a 1,408-meter span that links 2 continents. Building this bridge was an incredibly tough puzzle because it sits right above a busy shipping lane where massive vessels pass through day and night. Despite the constant pressure from strong winds blowing off the Black Sea, the bridge stands firm between the natural borders of Asia and Europe. With 2 towers rising over 320 meters, the structure looks like an engineering marvel suspended high in the Istanbul sky. To hold thousands of tons of steel over the vast open water, engineers used 176 incredibly strong hybrid cables. This bridge is a clear example of pushing past impossible limits, proving that we can overcome both the depth and the harsh conditions of the strait. Hanging high above the deep sandstone canyon, the Zhangjiajie Glass Bridge connects 2 vertical cliffs with a single, thrilling, transparent line. Stretching about 1,410 feet, the entire glass floor endures massive tension while suspended in mid-air without any supporting pillars beneath it. It stands as one of the longest pedestrian glass bridges in the world, breaking the limits of standard observation decks to provide a truly heart-pounding experience. The single-span suspension design makes the structure look like a delicate thread, yet it is firmly anchored by high-strength steel cables. The walkway is made of over 120 triple-layered glass panels, each about 2 inches thick, allowing you to look directly into the 980-foot abyss right under your feet. From the moment it opened, the bridge's popularity far exceeded all expectations, quickly becoming an iconic, suspended point in global tourism. This is Gardens by the Bay, a wonder built on reclaimed land in Marina Bay, demonstrating a truly ambitious effort to reclaim territory from the ocean. Built on a reclaimed foundation, this mega project faces massive engineering challenges to prevent seawater seepage and the constant risk of flooding as levels rise. At the heart of the garden, 18 massive super tree structures rise high, forming a surreal vertical forest that shades the vast open spaces located far below. The Flower Dome, the world's largest glass greenhouse at 1.28 hectares, is an architectural masterpiece of glass suspended in the air for all. This superstructure nurtures a massive ecosystem with over 500,000 individual plants from more than 5,000 different species in a grand biological vault. To experience the full scale of its magnificence, you can walk along the aerial walkways suspended between the super trees to observe the landscape from breathtaking heights. In China, Beijing National Stadium unfolds like a massive maze of interwoven steel, drawing the observer inward toward a vast open space sustained entirely by its exposed structural system. The stadium was built for the 2008 Olympics using over 42,000 tons of steel, while the original retractable roof design was removed to reduce load and improve stability. Inside, the seating tiers form a continuous loop, creating a unified viewing field from every position without interruption from large structural elements. The load-bearing system also acts as the exterior envelope, removing the traditional separation between structure and architectural surface across the entire building. For China, Beijing National Stadium is not only a competition venue, but also represents a stage where the country demonstrated organizational capacity, engineering capability, and the ambition to create a global architectural symbol. Rising amidst the Dubai financial district, the Museum of the Future appears as a surreal entity floating between the scorching desert and the modern urban landscape. Its silver, torus-shaped exterior, adorned with glowing Arabic calligraphy, makes the structure look like a futuristic spacecraft that has just landed from another world. Upon stepping inside, you are greeted by a column-free, three-dimensional space, creating the strange sensation of entering a mesmerizing and immersive digital realm. This is considered one of the world's most complex megaprojects, utilizing over 1,000 unique stainless steel panels joined with absolute mathematical precision. Standing 256 feet tall with a hollow center, this museum shatters all traditional architectural norms regarding standard solid, high-rise construction. By interacting with the advanced technologies of the year 2071, you truly experience why this structure is an impossible feat of modern engineering. Halley Research Station in Antarctica is built directly on a massive floating ice shelf, meaning the entire structure does not stand on land, but moves continuously with the drifting ice. The station is made of 8 connected modules, placed on lifting legs with skis, allowing the whole structure to be moved when the ice becomes unsafe. When stepping outside, it is easy to lose direction because everything is flat and white, with no landmarks or objects to judge distance clearly. Each year, about 70 people stay during stable periods, and the number drops to around 20 when conditions become much harsher. Inside, everything works as a closed system, where air, electricity, and daily life must be maintained without relying on the outside world. For several months without natural light, daily routines depend entirely on clocks and habits instead of normal day and night cycles. In Cornwall County of the United Kingdom, the Eden Project stands like a mechanical rebirth, rising from the depths of an abandoned clay pit nearly 200 feet deep. The steep rock walls surrounding the site once collapsed easily during heavy rain, threatening to bury every attempt to restore life at the bottom. Constructing massive steel domes inside the slippery crater created intense challenges because the weak clay ground could shift or sink without warning. Lightweight hexagonal roof panels made from advanced plastic show remarkable strength, as each thin cushion can support the weight of a single car. An intelligent water collection system captures around 42 million gallons of rain annually to sustain thousands of plant species, transforming lifeless terrain into a thriving ecosystem. Located at the boundary between Beijing and Hebei in China, Daxing International Airport rises like a vast steel flower spreading across open land. Valued at about $17 billion, the project required funding comparable to constructing dozens of the tallest skyscrapers simultaneously. The terminal covers nearly 7,500,000 square feet, and any failure in facial recognition or guidance systems could cause serious passenger confusion. Its roof structure contains roughly 30,000 tons of steel, a mass similar to combining 4 large iron towers into one framework. Large skylights across the dome maximize natural light, enabling travelers to reach departure gates within approximately 8 minutes on foot. The airport operates 4 runways with a combined length of about 9 miles, supporting one of the busiest aviation hubs in the world. In the desert city of Dubai, in the United Arab Emirates, Burj Khalifa rises like a steel needle, piercing the sky at nearly 2,700 feet. Construction workers operated at extreme heights where a single mistake could result in a fatal fall to the ground below. The tower's slender design must withstand intense wind forces and potential seismic movement that can cause noticeable structural sway. The reinforced steel used throughout the structure would extend about 6,200 miles if laid end to end, equal to roughly 1/4 of Earth's circumference. An advanced cooling system collects around 15 million gallons of water each year from air moisture to irrigate landscaped areas around the base. The exterior is covered with about 24,000 reflective glass panels, creating a brilliant surface that captures and mirrors the surrounding skyline. Rising in the Lujiazui Financial Center of China, Shanghai Tower twists upward like a massive crystal dragon spiraling into the upper atmosphere. Glass installers worked at heights reaching about 2,070 feet, where even a small mistake could lead to a fatal free fall. The structure weighs nearly 850,000 tons and must endure powerful tropical storms, moving inland from coastal waters. To stabilize the building, a tuned mass damper, weighing roughly 1,000 tons, was installed near the summit to reduce structural sway. The outer facade contains glass covering an area comparable to 20 standard soccer fields, forming a protective transparent shell around the tower. High-speed elevators travel upward at nearly 65 feet per second, reaching the 118th floor in less than 1 minute. Rising from the sands of Saadiyat Island, the Louvre Abu Dhabi appears as a unique marvel, standing at the edge of the sea and the desert sun. This mega project is the result of a historic partnership between the UAE and France, launching an incredibly ambitious cultural journey for the world. Composed of 55 small buildings, the museum resembles an ancient Arabic city brought to life right in the middle of the vast blue ocean. From a distance, the massive dome looks like a floating silver hemisphere, sheltering an art space covering more than 24,000 square meters. Engineers turned the impossible into reality by assembling the 7,500-ton dome directly over the sea and a foundation of concrete piles. Seen from above, the entire museum looks like a mirage city, where modern architecture blends seamlessly with the waves of the Persian Gulf. Running across the Yangtze River Delta region of China, the Danyang-Kunshan Grand Bridge stretches like a vast steel spine above wetlands and soft floodplains. Built over unstable ground, the elevated structure must resist serious settlement risks because its heavy concrete deck rests on compressible soil layers. Extending about 103 miles, it measures roughly 30 times longer than the Brooklyn Bridge and ranks among the longest bridges worldwide. Nearly 10,000 workers assembled around 360 feet of bridge structure each day, completing the immense project within just 4 years. Around 9,500 reinforced concrete piers were driven deep into the ground, forming a vast support network that keeps the railway surface stable. Positioned on the border between Guizhou and Yunnan provinces of China, Duje Bridge stretches across a vast canyon like a bright red ribbon suspended in the sky. Rising about 1,850 feet above the river below, the height creates extreme psychological pressure and serious danger for workers on scaffolding. Construction on hollow limestone cliffs required engineers to anchor support towers deep into unstable rock to prevent catastrophic structural collapse. This $150 million project consumed tens of thousands of tons of steel, enough material to recreate hundreds of massive Liberty statues. Giant steel cables support a main span of roughly 2,360 feet, allowing vehicles to cross the deep valley within only minutes. The bridge stands nearly twice as tall as the Eiffel Tower, establishing one of the most dramatic vertical crossings ever engineered above ground. Stretching across the narrow Isthmus of Panama in Central America, the Panama Canal serves as a vital waterway linking the Atlantic and Pacific Oceans. Construction faced deadly disease outbreaks and massive landslides that claimed about 25,000 lives during the difficult excavation through mountainous terrain. Ships weighing tens of thousands of tons pass through massive lock chambers with only inches of clearance from the concrete walls. Roughly 7 billion cubic feet of earth and rock were removed, an amount sufficient to reconstruct dozens of the largest ancient pyramids. A gravity-driven lock system raises vessels approximately 85 feet above sea level without relying on electric pumping machinery. This historic engineering achievement reduced sea voyages by weeks, transforming a remote tropical corridor into one of the busiest trade routes worldwide. Located on the border between the states of Nevada and Arizona in the United States, Hoover Dam rises as a massive concrete barrier across the Colorado River. During construction, workers suspended from desert cliffs faced extreme danger while drilling diversion tunnels through solid canyon rock. The enormous concrete mass generated intense internal heat as it cured, requiring a complex cooling system to prevent cracking and structural damage. Enough concrete was used to build a highway stretching from New York to San Francisco, crossing the entire width of the country. The reservoir behind the dam stores enough water to cover a vast region under about 1 foot of water. Turbines housed within the structure produce electricity that supplies power to more than 1 million people each year. Dominating the Tarn Valley in southern France, the Millau Viaduct rises like a giant vessel suspended above a sea of clouds. Construction at elevations exceeding about 650 feet exposed workers to strong winds and serious danger without strict safety protection. The elegant structure rests on 7 slender towers that required detailed geological surveys to secure foundations within limestone beneath the valley. The tallest point reaches nearly 1,125 feet, surpassing the height of the Eiffel Tower and becoming the highest structure in France. Hydraulic launching systems pushed the heavy deck segments weighing thousands of tons across open air with remarkable precision. Around 206,000 tons of concrete were used for the piers, exceeding many times the metal weight incorporated in the Eiffel Tower. Spanning the Baltic Strait between Denmark and Sweden, the Øresund Bridge stands as a major transport link combining bridge, tunnel, and artificial island in one system. During construction, divers discovered 16 unexploded World War II bombs resting on the seabed, forcing careful removal before marine work could continue safely. Winter ice flows drifting across the strait exert crushing pressure against the steel piers, requiring reinforced supports to withstand seasonal impact force. An artificial island was formed using nearly 5 billion cubic feet of dredged material, enough volume to fill more than 50 large stadiums. The underwater tunnel section consists of prefabricated concrete elements weighing about 55,000 tons each, comparable to the mass of a large. Steel used in the cable-stayed span equals the weight of roughly 10 Eiffel Towers combined, creating a stable structure above open sea waters. Located at the Three Gorges Dam on the Yangtze River in Hubei Province, China, the shiplift stands as a towering mechanical chamber moving vessels vertically along the massive barrier. The platform can transport about 15,500 tons in a single operation, making it one of the heaviest vertical lifting systems ever constructed. A network of 256 reinforced steel cables works together to raise ships nearly 370 feet above the river level. Advanced control software continuously balances water pressure and weight distribution to prevent the suspended basin from tilting during movement. The entire lifting cycle takes roughly 40 minutes, replacing a former passage process that required close to 4 hours through traditional locked chambers. Completed in 2016, the structure improved cargo capacity along the Yangtze and strengthened regional inland water transport efficiency. Atravessando o Estreito Istmo na Grécia, o Canal de Corinto aparece como um corte profundo ligando dois mares por uma linha reta impressionante. Grandes embarcações enfrentam risco extremo ao navegar por um corredor com apenas cerca de 21 metros de largura, cercado por paredões verticais. A instabilidade geológica provoca deslizamentos frequentes que podem lançar aproximadamente 60 mil metros cúbicos de rocha dentro do canal profundo. As paredes naturais alcançam cerca de 90 metros de altura ao longo de aproximadamente 6 quilômetros, formando um desfiladeiro comparável a um prédio de 30 andares. O empreendimento secular transformou a península do Peloponeso em uma ilha separada após a escavação bem-sucedida das camadas rochosas resistentes. Pontes nas extremidades do canal podem submergir automaticamente, permitindo passagem contínua de navios entre as baías conectadas. Located on an artificial island off the coast of Hong Kong in China, Hong Kong International Airport stands like a vast transport platform rising from the South China Sea. Built with an investment of about $20 billion, the development required funding equal to reconstructing the Eiffel Tower roughly 40 times. Operating on reclaimed land demands continuous ground monitoring to prevent settlement if underlying soil layers are not properly compacted. The airport covers nearly 3,100 acres, an area comparable to about 1,700 standard soccer fields combined. Floor-to-ceiling glass walls allow passengers to observe large aircraft taxiing beneath an elevated pedestrian bridge inside the terminal complex. An underground baggage handling system extends about 15 miles in total length, moving tens of thousands of suitcases efficiently each day. Masdar City in Abu Dhabi stands as a uniquely remarkable urban megaproject worldwide for its absolute commitment to eliminating any footprint of gasoline-powered vehicles. You will be amazed by the autonomous personal rapid transit system of driverless vehicles running on modern underground tracks to serve the residents' transportation needs. The entire infrastructure here operates using a massive energy source harvested from a solar farm spanning 54 acres in the surrounding area. Buildings constructed from terracotta materials and 90% recycled aluminum help this architecture challenge every limit of durability in the desert environment. The ultra-narrow street planning combined with sophisticated perforated geometric shells helps to shield solar radiation in the most effective way. Masdar City has proven the ability to transform human life through recycling 100% of wastewater and processing waste into clean energy. On the legendary Blue Nile in Ethiopia, the Grand Ethiopian Renaissance Dam stands as a massive concrete fortress, challenging all technical limits. The project used 13.4 million cubic yards of roller-compacted concrete, enough to pave a road from New York to Mexico City. With a height of 475 feet equal to a 45-story tower, this artificial wall blocks the natural flow to create endless energy. The giant reservoir covering 724 square miles submerged old valleys and turned high hilltops into 70 scattered artificial islands. This megaproject, with a capacity of 5,150 megawatts, will provide electricity for 60 million people and completely change the regional economy. It serves as a symbol of self-reliance as the Ethiopian government raised the entire $4.8 billion from its own citizens instead of borrowing. Shinkansen is a massive high-speed rail network stretching over 1,800 miles across Japan, connecting various regions through a complex system of tracks. These super projects feature trains capable of operating steadily at 200 miles per hour, significantly reducing travel time between different areas. The 49-foot-long nose of the train is engineered based on aerodynamic principles to eliminate air pressure when traveling through tunnels. The automatic safety system triggers emergency brakes immediately upon sensing the first seismic waves to provide absolute protection for all passengers. Throughout over 60 years of continuous operation, this extraordinary transportation network has never recorded a single fatality due to technical track failures. Approximately 420,000 people use the service every day, making Shinkansen one of the most impactful engineering feats on modern society. At the border of Brazil and Paraguay, Itaipu Dam stands as a massive concrete monster dominating the powerful flow of the Paraná River. This megaproject consumed 16.1 million cubic yards of concrete, enough to pave a wide road connecting New York all the way to Los Angeles. This monumental structure is nearly 5 miles long and 643 feet high, creating an unbelievable artificial wall challenging all engineering limits. The giant reservoir, spanning 521 square miles behind the dam, stores billions of tons of water, exerting immense pressure on geological structures. Itaipu is not just a power machine, but also represents the human ambition to conquer nature on a planetary scale. You are looking at the Songdo International Business District in Incheon, a futuristic megacity built entirely on 1,500 acres of land reclaimed from the Yellow Sea. This impossible project cost over $40 billion in private investment to transform open water into a modern financial hub, defying all limits. The greatest difference lies in the 12-mile-long underground pipe system that automatically sucks all resident waste to a central processing plant. Smart urban planning allows people to access all essential amenities within a 15-minute walk to completely eliminate dependence on private cars. The landscape here is extremely impressive, with green space occupying 40% of the total scale, providing a clean and absolutely sustainable living environment. Songdo International Business District is a vivid testament to human capability in harnessing nature and redefining the modern urban experience. The Karakoram Highway is a massive 800-mile infrastructure project that cuts through the highest mountain ranges at the border of Pakistan and China. This eighth wonder of the world reaches a record height of 15,397 feet, where thin air challenges heavy machinery. The 20-year construction process mobilized tens of thousands of workers to carve through solid rock and bridge immense vertical abysses. The human cost was staggering, as one worker died for every 1 mile of road completed due to the extremely rugged terrain. This megaproject is engineered to withstand powerful seismic shifts from tectonic plates that constantly collide deep beneath the Earth's surface. This vital international artery now facilitates global trade and has completely transformed the economic landscape of the entire region. Deep inside the frozen mountains of Norway, The Svalbard Global Seed Vault stands as a massive super project protecting the life source of our entire planet. This giant steel entrance leads into a tunnel 430 feet long through solid limestone to reach the storage area. Within this technically challenging structure, more than 1.2 million seed samples from almost every nation on Earth are currently preserved. The system has a maximum capacity of 2.25 billion seeds to ensure global food security against major disasters. The construction site sits 430 feet above sea level to help the project avoid flooding risks from climate change. This is a unique backup fortress that helps humanity rebuild agriculture if domestic gene banks are completely destroyed. The Bailong elevator stands firmly against the sandstone cliffs of Zhangjiajie, China, as an architectural marvel that defies all conventional physical boundaries. This massive structure reaches a total height of 1,070 feet, officially setting the Guinness World Record for the tallest outdoor elevator on the planet. The giant steel frame allows 3 glass cars to operate simultaneously, carrying 150 passengers into the air in just a moment. This extraordinary speed enables humans to conquer a height of 1,000 feet in less than 90 seconds, completely replacing hours of strenuous climbing. The vertical shaft system boring through quartz mountain rock provides a panoramic view of giant sandstone pillars rising high into the open space. This impossible megaproject proves human ambition in redefining the way we travel and experience the magnificent beauty of the natural world. In the Netherlands, the Delta Works stands as an extraordinary superstructure designed to completely subdue the power of the cold and fierce North Sea. Honored by the ASCE as one of the 7 wonders of the modern world, this project has entirely transformed the appearance of the coastline. Engineering prowess allows humans to shorten the direct contact path with the sea from 435 miles to just about 15 miles. Concrete pillars weighing 18,000 tons stand tall in the ocean with durability designed to fail only once every 10,000 years. This massive steel shield system is responsible for protecting more than 4 million people living and working right below sea level. The Delta Works megaproject is a testament to the incredible efforts of humanity in redefining the boundaries between land and water. The Qinghai-Tibet Railway in China is an unimaginable megaproject that successfully conquered the harshest and highest plateau regions on the entire planet. Reaching a peak elevation of 16,640 feet, this train operates at an altitude equivalent to half the flight path of commercial airliners. Engineers installed thousands of liquid ammonia heat pipes to keep 550 miles of ground frozen solid even during the summer. Every train car features an airtight design equipped with a forced oxygen supply system to help passengers maintain stable breathing conditions. Miles of long, elevated bridges were meticulously constructed to fully protect the natural environment and the migration paths of wild animals. This railway line has completely transformed travel methods and opened a new era for resource exploitation in this remote land. The Lake Pontchartrain Causeway in Louisiana is an architectural marvel running straight through the heart of a lake with a challenging structure. This megaproject possesses an incredible total length of 23.87 miles and is supported by 9,500 concrete pilings. Upon reaching the 8th mile, the land completely vanishes from sight, forcing drivers to face a vast expanse of open water. The landscape here is unique due to power lines appearing to sink below the horizon because of the direct effect of Earth's curvature. Mass production techniques allowed for lightning-fast completion, while ensuring the structure could withstand extreme compression of 10,000 pounds per square inch. The Lake Pontchartrain Causeway has maintained its Guinness World Record as the longest continuous bridge over water for more than half a century. The Akashi Kaikyo Bridge in Japan is a grand mega-project spanning the fierce Akashi Strait with an incredibly overwhelming construction scale. This wonder possesses two giant tower shafts, 978 feet tall, equivalent to a skyscraper, helping support the entire massive steel structure. The total length of the small steel wires making up the main cable system reaches 186,000 miles, enough to wrap around the Earth more than 7 times. The construction process, lasting for 10 years, mobilized more than 2 million workers to turn this impossible design into a reality. The bridge serves as a vital artery by shortening the sea travel time from many hours down to only 5 minutes. The presence of Akashi Kaikyo not only changes how humans exploit nature, but also confirms the era transcending engineering power of humanity. The Julius Nyerere hydropower plant in Tanzania stands as an ambitious energy megaproject constructed directly upon the powerful currents of the Rufiji River. The artificial reservoir of the station can store up to 1,165 billion cubic feet of water, transforming the wild valley into a vast inland sea. Nine advanced turbines installed deep within the mountain provide a capacity of 2,115 megawatts of power to drive comprehensive industrialization. The execution of this megaproject required extraordinary efforts from thousands of workers to transport super-heavy machinery across extremely rugged and difficult terrain. Julius Nyerere is not only a symbol of modern engineering, but also completely changes how humans harness natural resources across the entire continent. Hidden beneath Russia, Moscow Metro opens an underground world where wide corridors and massive structures make people forget they are standing below the surface. The system reaches about 240 feet deep, requiring engineers to constantly manage soil pressure and groundwater to maintain structural stability. Interior spaces follow strong symmetry, with stone columns and vaulted ceilings distributing forces evenly to keep the structure stable at depth. By early 2026, the system has more than 300 stations and extends over 330 miles, ranking among the longest metros in Europe and beyond China. Since opening in 1935, the network has grown into a high-capacity system supporting daily urban movement at a massive scale. For Moscow, the metro not only handles transportation, but also shapes urban identity, as many residents see it as an essential part of everyday city life. In Iran, Milad Tower appears as a dominant vertical axis rising above the skyline, where a massive structure separates itself from the surrounding urban rhythm below. Inside, 6 elevators move at about 20 feet per second, significantly reducing the time needed to reach upper levels compared to normal perception. The project lasted more than 11 years, requiring strict control of vibration and structural movement to maintain stability under complex environmental conditions. Its slender shaft, combined with an expanded upper section, forms a non-traditional shape, making the tower resemble a suspended engineering system rather than a familiar building. Milad Tower was ranked as the 6th tallest telecommunications tower in the world and the tallest in Iran, making it highly visible on the global architectural map. In the United States, Evergreen Point Floating Bridge appears across deep water as a roadway without ground support, immediately raising questions about how such a structure can remain stable. The entire system is formed by 77 massive hollow concrete pontoons that rely on buoyancy, allowing the bridge to remain steady under continuous daily traffic loads. At the central section, the roadway drops close to the water, creating the sensation that vehicles move directly across the surface instead of traveling on an elevated structure. Completed in 2016, the bridge includes multiple traffic lanes and protection systems designed to maintain performance under strong wind conditions and long-term environmental stress. Inside each pontoon are sealed compartments with monitoring systems that allow the structure to remain afloat even if an individual section experiences unexpected damage. In Singapore, there is a place where the first glance makes people pause, as Marina Bay Sands rises like a structure that seems to move beyond familiar logic and expectations. The infinity pool holds about 376,000 gallons of water and reaches the edge, creating a seamless visual connection between water and the distant skyline. The Sky Park functions as a separate elevated platform above the towers, carrying soil, vegetation, and walkways that form a complete artificial landscape. The building stands on reclaimed soft ground, requiring deep foundations and complex structural systems to stabilize the massive load above. A projecting section extends outward from the main structure, producing a visual imbalance that makes the entire form appear as if it is shifting in space. During construction, steel sections weighing about 1,400 tons were lifted and assembled at height, with extremely tight tolerances. Hidden within Romania, Palace of the Parliament stands as a massive structure layered with material weight, creating a sense of pressure that is difficult to fully explain. The building weighs over 4 million tons and includes more than 1,000 rooms, placing it among the largest administrative structures ever constructed worldwide. More than 20,000 workers and hundreds of architects contributed over several years, forming a construction effort that operated on a national scale with constant technical pressure. The interior uses vast quantities of marble, wood, and crystal, making each room feel physically dense rather than open or minimal in design. Large halls and extended corridors reshape spatial perception, causing people to lose orientation while moving through different sections of the interior. Some carpets were finished directly inside because they could not pass through entrances, showing how construction dimensions exceeded normal building limits. Across the United States, Denver International Airport was built within a vast open landscape where white tent roofs create a visual identity that differs from typical aviation infrastructure. The most noticeable artwork is a blue horse with glowing red eyes, an image so strong that it has moved beyond decoration into popular cultural recognition. The airport opened in 1995 after a prolonged construction period marked by debates over cost and delays, drawing national attention as a major infrastructure project. The airport covers about 53 square miles, making it the largest commercial airport in the United States by land area and among the largest globally. Runways are spaced far apart, increasing operational capacity and reducing overlap between aircraft movements during periods of heavy traffic. In Singapore, Jewel Changi Airport unfolds as an enclosed environment where trees and flowing water coexist, raising the question of who turned an airport into a nature-like experience. Inside, a central waterfall about 130 feet drops from a glass roof across multiple levels, creating the impression of a natural system within a man-made structure. Jewel received the International Architecture Award in 2016, recognizing its design quality and innovation, confirming its strong position in modern global architecture. As visitors move along curved pathways across levels, the space expands vertically, creating the sense of walking through a forest contained within a controlled environment. The complex includes more than 300 retail and dining spaces, turning it into a destination where people stay rather than simply pass through during travel. Few notice that water from the waterfall is collected and reused continuously, forming a closed-loop system that maintains the landscape over extended periods. In China, Shanghai Maglev train operates as a vehicle moving through open space, where motion without physical contact creates a completely different experience from traditional railway systems. Maglev technology uses electromagnetic force to lift the train above the guideway, removing rolling friction and allowing much higher speeds than conventional rail systems. The project began construction in 2001 and started commercial operation in 2004, becoming the first high-speed maglev line used in regular service. The levitation system keeps the entire train body suspended above the guideway, eliminating mechanical friction and transforming the fundamental principle of rail transportation. The project faced public opposition due to concerns about electromagnetic radiation and environmental impact, showing that new technologies often come with social debate. Although it has not been widely expanded due to high cost, it still serves as a research foundation for many maglev developments around the world. In Australia, Sydney Harbour Bridge was formed by two steel arches extending toward the centre and locking precisely, creating a structure that balances itself across open space. The bridge was completed in 1932 using about 53,000 tons of steel and over 6 million rivets, forming a dense mechanical structural system. It differs by carrying rail, vehicles, pedestrians, and bicycles within one integrated system, functioning as a unified multi-layer transport structure. The main challenge was aligning the two arches from opposite sides, where even a small deviation could disrupt the entire load, bearing logic. The nickname coat hanger comes from its steel arch shape resembling a hanger, reflecting how the structure became easily recognized in public perception. From a technical perspective, the bridge serves as both essential infrastructure and a national image where functional use and symbolic value closely overlap. In China, Baihetan Dam rises within a deep canyon as a massive curved wall where a river is restrained to support large-scale energy production. The facility has a capacity of 16 gigawatts, using 16 units rated at 1 gigawatt each, placing it among the most powerful hydropower stations ever operated. Two underground powerhouses extend about 1,440 feet in length and nearly 300 feet in height, creating internal spaces that are difficult to fully visualize. In Malaysia, Petronas Towers rise as two identical structures. Once the tallest buildings in the world from 1998 to 2004, and still the highest twin towers globally. The design includes 88 floors arranged in strong vertical repetition, creating a stretched visual effect that makes it difficult for the eye to identify the true endpoint. A sky bridge connects the towers at about 130 floors above ground, functioning both as a passage and as a structural element that reduces wind movement. The exterior uses stainless steel and glass, allowing the towers to reflect changing sky conditions and appear lighter than their actual structural mass. The two towers were built by separate contractors at the same time, creating a rare construction race that directly influenced the speed of project completion. The structure combines Islamic geometry, deep foundation engineering, and a twin tower layout, forming a rare design where multiple technical and cultural elements exist together. This is Taipei 101, the proud symbol of Taiwan, a super project constructed directly atop a zone of intense seismic activity and extreme weather conditions. Featuring 101 floors above ground and 5 basement levels, this 509-meter tower stands firmly on a foundation 80 meters deep to defy the constant threat of earthquakes. engineers turned the impossible into reality by designing the structure to withstand violent seismic events of magnitude 7 on the Richter scale. With a massive total floor area exceeding 412,000 square meters, this megaproject represents a monumental achievement in vertical architectural scale. The most astounding feature is a massive 660-ton steel pendulum suspended seat acting as a metallic heart that stabilizes the tower against powerful vibrations. The architectural language deeply integrates cultural symbolism, repeating the lucky number 8 throughout its design to represent eternal prosperity and growth. Emerging from the skepticism of the 19th century, the Golden Gate was once called the bridge that could not be built due to violent waves and depths. With two towers rising 746 feet through the thick fog, this mega structure looks like a ribbon suspended high above the treacherous open water. The name Golden Gate actually refers to the strait itself, which serves as the vital gateway connecting San Francisco Bay to the vast Pacific Ocean. From a distance, the bridge appears as a massive curve held by a giant cable system, flowing elegantly across the wide and windy coastal void. While traveling across the 1.7-mile span, you can feel a slight vibration as the entire steel structure adapts to the powerful ocean forces. This is a grand engineering symbol where humans successfully conquered the harshest natural barriers to link two distant shores together forever across the sea. Stretching endlessly across the vast Tagus estuary, the Vasco da Gama Bridge appears as a colossal ribbon linking the shores of Lisbon. With a total length of over 10.7 miles, this mega structure was crafted from 100,000 tons of steel and over 730,000 cubic meters of concrete. Construction was an ultimate challenge, as engineers had to tackle soft marshlands and unstable riverbeds with incredibly complex, deep foundation solutions. While driving across the span, you will feel as if you are gliding directly over the water, surrounded by a vast open space with no obstacles in sight. The wide water surface reflects the sky, creating a stunning visual effect where the horizon between the sea and the heavens almost disappears. Completed for Expo 1998, the bridge is more than just infrastructure. It stands as a grand symbol of Portugal's modern engineering ambition. Linking the island shores across the Seto Inland Sea, the Great Seto Bridge appears as a colossal 8-mile ribbon connecting Honshu and Shikoku. It stands as the world's longest double-deck bridge, creating a spectacular sight where cars travel on the upper level while trains rush through below. From above, the structure curves gracefully across 5 small islands, looking like a brilliant metallic strand laid out over the blue ocean. This is one of the few megaprojects globally that integrates both a highway and a railway within a single steel framework, stretching for miles. Situated in a high-activity earthquake zone between tectonic plates, the bridge is engineered as a structural fortress, able to withstand violent seismic tremors. The entire 8.1-mile system is built to endure constant shaking and intense pressure, maintaining perfect stability in the heart of the sea. This is the Baluarte Bridge, a structural marvel perched amidst the rugged canyon of the Sierra Madre Occidental, linking 2 vertical cliffs where central supports are impossible. In an environment defined by extreme weather, from lightning storms to high winds, the structure stands firm on a foundation of complex volcanic rock. Previously, the highest cable-stayed bridge in the Americas, its massive cables fan out from the towers, visibly holding the entire weight of the span in tension. Driving across offers you a dizzying, panoramic view of the mountains, transitioning through a sequence of 60 winding tunnels. This is the Russky Bridge, an engineering marvel connecting Vladivostok to Russky Island across the turbulent eastern Bosphorus Strait. With two A-shaped towers soaring 1,050 feet high, the structure acts as a pair of giant gateways in Peter the Great Gulf, surrounded by deep blue waters and dense forests. The entire 10,000-foot system was meticulously designed to withstand the intense seismic activity and harsh conditions of the Russian Far East. Completed in 2012 for over $1 billion, it was once called the Bridge to Nowhere because it led to a formerly secret military base. Its significance is so profound that the bridge has been featured on the Russian 2,000 ruble banknote since 2017. Today, it stands as a perfect destination for travelers, blending the cultural heritage of Vladivostok with the pristine natural beauty of Russia's coastal islands. Rising elegantly from an artificial island 920 feet off the Jumeirah coast, the Burj Al Arab stands as a masterpiece of modern offshore structural engineering. To secure this 1,050-foot skyscraper, engineers drove over 200 massive concrete piles deep into the saturated sand instead of using solid rock. Shaped like the sail of a traditional dhow, the building features a grand atrium enclosed by two majestic wings that rise high above the Persian Gulf. Standing inside the magnificent interior, it is difficult for you to imagine that the entire massive structure is actually resting on a foundation of undersea sand. Thousands of tons of rock and dredged material were used to create a solid base capable of resisting ocean erosion and powerful 75-mile winds. It remains one of the few high-rise buildings in the world constructed entirely on a man-made island, representing a landmark of architectural innovation today. Right in Lower Manhattan, One World Trade Center shines like a massive crystal, built directly on complex ground near the city's high harbor water table. To handle urban winds reaching 140 miles per hour, the tower relies on thick reinforced glass and a specialized internal mass damping system. It took 8 years of intense work at the Ground Zero site before the building finally opened its doors to the public in late 2014. The most interesting feature is how the glass faces shift angles as they go up, catching the sunlight differently depending on where you stand. A heavy concrete base provides essential security for the structure, sitting quietly next to the emotional reflecting pools of the nearby Memorial Square. Millions of people line up every year for the observatory, where you can catch a perfect view of the sunset spreading across the entire city. Situated in Kuala Lumpur, Merdeka 118 anchors itself into porous soil using a massive raft foundation and 8 giant mega columns to support its incredible weight. To remain stable during intense tropical storms, the structure relies on a high-strength concrete core connected to a complex system of internal steel outrigger trusses. The building's jagged silhouette is a direct tribute to the historic gesture made by Malaysia's first leader during the independence ceremony of 1957. When looking from afar, the skyscraper appears as a sharp needle piercing the sky, with multifaceted glass panels reflecting sunlight in many different directions. Engineers used advanced vibration sensors throughout the project to ensure that the adjacent historic stadium remained completely undisturbed during the massive underground excavation. Today, the site offers you a chance to stand at an impossible height, blending a deep sense of national identity with world-class architectural innovation. Built directly over the active West Side Yard, Hudson Yards rests on two massive concrete and steel platforms weighing 35,000 tons above the busy train tracks. Engineers installed 300 deep caisson piles into the solid bedrock between moving trains to provide a stable foundation for this incredible artificial ground. A powerful ventilation system with 15 large fans cools thousands of trees while clearing heat and exhaust from the locomotive engines operating underneath the platform. From an aerial view, the entire complex looks like a separate city placed onto a 28-acre floating deck high above the railway system. This project stands as one of the largest private real estate developments in American history, transforming a former industrial space into a modern urban center. You can explore the green parks and the High Line connection while enjoying a perfect sunset view over the Hudson River from this modern oasis. Standing on Sadu Bet Island, the Statue of Unity reaches a height of nearly 600 feet, making it the tallest monument in the world. The massive structure was engineered to withstand intense winds of over 100 miles per hour and significant seismic activity in the Narmada River region. This monument honors Vallabhbhai Patel, the Iron Man of India, who successfully unified 562 princely states into a single nation.